Welcome to another episode of the Aurora Generators podcast. Today, we're diving into something really important, maybe a bit overlooked sometimes for anyone running a diesel generator. It's called diesel wet stacking.
Ah, yes, wet stacking. It sounds, well, not great, does it? And it can be a real headache if you don't manage it.
Exactly. It can seriously impact performance, even shorten the life of your generator.
Mm,
So, uh, our goal today is to really unpack this for you.
right. We want you to understand what it actually is, what causes it, the damage it does, and crucially, how you can prevent it from happening in the first place.
And we'll also hit on some key questions like,
Mm,
is this covered by warranty? Big one, that. And can you actually fix it yourself if it's already started?
yeah, those are critical points. So basically, we want to give you the clear, actionable info you need to keep your generator running smoothly, reliably.
Okay, so let's start right at the beginning. What is wet stacking? I've heard it called engine slobber, which is
Mm,
descriptive.
Huh. It is descriptive, isn't it? Basically, wet stacking is when unburned diesel fuel and maybe some engine oil build up inside the exhaust system. It forms this thick, dark, sludge-like gunk. The name's pretty literal. It's wet from the unburned fuel, and it's happening in the exhaust stack.
Okay, so you'd actually see this stuff.
Oh, absolutely. You'll spot it as this black, kind of oily ooze, maybe around the exhaust pipe connections, sometimes on the turbocharger itself, definitely coming out the tailpipe.
And it looks like oil, but it isn't quite.
Yeah, you might mistake it for engine oil at first glance, but it's usually thicker. And if you get close enough, it definitely smells like diesel fuel. Essentially, it's made up of the heavy ends of the diesel fuel. Think of the parts of the fuel that are, well, harder to burn off. They need more heat.
Right, the less volatile components, that makes sense. Now, is this something all generator owners need to worry about? Like if I have a gasoline generator, am I in the clear?
Good question. And the answer is generally yes. You're in the clear with gasoline. Wet stacking is pretty much exclusively a diesel engine issue.
Why is that?
Well, gasoline engines just naturally run hotter, much hotter actually. So any excess fuel usually gets burned off without much trouble. Diesel fuel, on the other hand, it's much less volatile. Its initial boiling point is way higher. Think around 300 degrees Fahrenheit compared to maybe 100 for gasoline.
Wow, quite a difference.
Huge difference. So diesel needs significantly higher temperatures and sustained temperatures to burn completely and cleanly. If it doesn't get that heat, well, that's where the problems start.
Okay, so that leads us right into the causes. If diesel needs high temperatures, I'm guessing the main cause involves not reaching those temperatures.
You've got it. The number one culprit, hands down, is low load operation.
Running it too gently, basically.
Exactly. It happens when a generator runs frequently with very little or sometimes even no electrical load connected to it. Or another common scenario is when the generator itself is just too big for the job it's doing. It's oversized for the actual demand.
Right, so it never really has to work hard.
Precisely. When a diesel engine runs at less than, say, 30% of its rated capacity for long stretches, and some experts say even anything below 60% can be risky over time, it just can't maintain the optimal operating temperatures.
And without that heat.
Without that heat, the fuel doesn't burn completely. A significant amount just passes right through the combustion chamber and into the exhaust system as unburned fuel vapor or droplets. That's your wet part.
It's like asking a marathon runner to just stroll around the block all day. They're built for more.
That's a great analogy. They need to be worked. But it's not only about low load, that is the big one. There are other factors that can contribute too.
Okay, like what else?
Well, sometimes things related to engine pressure can play a part. If the pressure inside the combustion chamber drops too low, maybe below the pressure in the crankcase, the piston rings might not expand properly.
Ah, so they don't seal as well.
Exactly. They need that pressure to really seal tight against the cylinder walls. If they don't, you can get fuel and oil slipping past. Also, issues with the fuel system itself. Think excessive fueling, maybe weak or leaky injectors that aren't spraying a fine mist but are sort of dumping fuel in.
Or the settings are just wrong.
Or the fuel settings are just cranked up too high, yeah. An incorrect air-to-fuel ratio is another one. Not enough air for the amount of fuel.
Makes sense.
And then there are environmental things like running the engine constantly in very cold weather without letting it warm up properly. Prolonged idling is a classic contributor too.
Just letting it sit there, running with no load.
Terrible for it, really.
Yeah.
And even infrequent use can be a factor. If a generator sits for long periods, moisture can build up inside, which doesn't help things when it does run.
Okay, so a whole collection of potential causes. But low load is king. Now we know what it is and why it happens. Let's talk about the damage. What does this engine slobber actually do inside the engine and exhaust? It sounds more than just messy.
Oh, it's far more than messy. The effects are quite insidious and can spread throughout the engine. First off, it fouls things up. Fuel injectors get coated, which stops them from spraying that nice, fine pattern needed for good combustion. They start to, well, perform poorly.
So worse combustion, more unburned fuel.
Exactly. It's a vicious cycle. It also causes excessive wear on valve guides, and in worst cases, it can lead to damage to the pistons themselves, the piston liners, and the rings, the very core components. You get this buildup of carbon deposits and unburned fuel residues on pretty much all the internal engine parts, and it continues downstream into the exhaust system, affecting mufflers, catalysts, everything.
You mentioned piston rings earlier. I've also heard the term glazing connected with wet stacking. That sounds particularly bad.
Glazing is it's a serious consequence. What happens is because the engine isn't working hard enough, those combustion pressures are low. The piston rings don't seal tightly, like we said. Hot combustion gases can then blow past the rings. When these hot gases hit the lubricating oil film on the cylinder walls, they can essentially flash burn it.
Bake it on?
Sort of, yeah.
Yeah.
It creates this hard enamel-like glaze on the cylinder walls. We call it bore glazing or cylinder glazing.
And why is that so bad?
Yeah.
Sounds smooth, maybe.
But you don't want the cylinder walls perfectly smooth. They're manufactured with these microscopic crosshatch patterns called honing marks. They're designed specifically to hold a thin layer of lubricating oil.
Okay.
When glazing occurs, it fills in or smooths over these crucial honing marks. The cylinder wall becomes too smooth, almost polished. This is called bore polishing.
And the consequence of that?
Well, the wall can't hold oil properly anymore. This leads to increased oil consumption. You might start seeing blue smoke from the exhaust, which is burning oil. And critically, it makes the ring sealing even worse, allowing more fuel and combustion gases to bypass.
So it just keeps getting worse. What about the engine oil itself? Does the unburned fuel affect it directly?
Absolutely. This is a major problem. Unburned fuel leaking past those poorly sealed piston rings gets into the crankcase and dilutes the lubricating oil.
Making it less effective.
Significantly less effective. It reduces the oil's viscosity and its ability to protect engine parts, leading to, accelerated wear on bearings, camshafts, everything. Plus, you can get acids forming in the oil. Water vapor, a byproduct of combustion, can condense, and mixed with other combustion byproducts, it forms acids that attack bearing surfaces over time. Nasty stuff.
Wow. And I imagine all that gunk in the exhaust system must cause issues too.
Definitely. All that buildup creates increased exhaust back pressure. The engine has to work harder just to push the exhaust out, which hurts efficiency. And if you have a turbocharger, those deposits can build up on the turbine blades, reducing the turbo's efficiency, meaning less air getting into the engine, further worsening combustion.
It really is a cascade of negative effects.
Okay.
So summing up the damage, poor performance, higher fuel use, what's the long-term outlook for a generator suffering from this?
The long-term outlook isn't good if it's not addressed. You're looking at decreased engine performance, definitely lower efficiency, meaning you burn more fuel for the same power output, and just generally reduced power capability.
It might run rough.
Yeah, the engine might misfire, run unevenly, maybe produce continuous black smoke even when it's under a steady load, which is different from the puff of smoke on startup. In really extreme, rare cases, the accumulated fuel in the exhaust could potentially ignite if temperatures suddenly spike, which is obviously very dangerous.
Good grief.
But the main thing is, unchecked wet stacking significantly shortens the engine's lifespan. We're talking potentially shaving years off its operational life and leading to much higher maintenance and repair costs down the line. It's a slow killer for generators.
And I guess in today's world, there are emissions concerns too.
Big time. All that incomplete combustion means higher emissions of nasty stuff. Carbon monoxide, nitrogen oxides, unburned hydrocarbons, particulate matter. And think about modern diesel generators. Many have sophisticated after-treatment systems to meet emissions regulations, things like diesel oxidation catalysts, or DOCs, selective catalytic reduction, SCR systems, diesel particulate filters, DPFs.
Right, all that complex tech.
Well, these systems are very sensitive to operating conditions. They often need specific high exhaust temperatures to work correctly. Low-load operation and wet stacking prevent them from reaching those temperatures.
So you could fail emissions tests.
You could absolutely fail emissions tests, yeah. It can cause the after-treatment systems to become clogged or ineffective, leading to compliance issues and potentially more repair costs.
Okay, this has been, well, frankly, a bit alarming, outlining all the ways wet stacking can damage a generator. But the good news, I hope, is that it's preventable.
Yes, absolutely. The good news is that wet stacking is largely preventable with the right operating practices and maintenance. We can definitely fight back against it.
So let's shift gears to solutions. What's the single most effective way to prevent or even reverse early-stage wet stacking?
The gold standard, the most widely recommended solution, is load banking.
Load banking. Explain that for us.
Sure. Load banking involves connecting the generator to an artificial electrical load, basically, a device that simulates real-world electrical demand. The whole point is to deliberately force the generator to work harder, to run under a significant load. This raises the engine's internal temperatures and pressures up to their optimal operating range.
And that heat does what?
It burns off the accumulated gunk. That higher temperature allows the engine to properly combust any unburned fuel residues and carbon deposits that have built up in the cylinders and exhaust system. It's like giving the generator a really good internal cleaning through hard work.
A workout, like you said earlier. So how often should you do this and how hard do you need to push it?
Well, recommendations vary slightly, but a common guideline for many manufacturers is to perform a load bank test monthly.
Monthly, okay.
Yeah, for at least 30 minutes, and the load should be at least 30% of the generator's rated capacity. Some sources are actually more aggressive, suggesting you really need to hit 75% or even more of the maximum load to get things truly hot enough.
So somewhere between 30 and 75% consistently.
Ideally, operating regularly between, say, 40% and 75% of the maximum rated load is a great zone for keeping things healthy during normal use or testing. The key is avoiding those prolonged periods of very low load.
Now, I heard something interesting recently that modern engines might be changing the game a bit here. You mentioned advancements earlier.
Yes, this is a really important point, especially for people looking at newer equipment or managing modern fleets. Technology has come a long way. Modern diesel engines, particularly those using things like common rail fuel injection systems, advanced charge air cooling, and much tighter tolerances in piston and ring design think engines from makers like Perkins or Caterpillar, for example, are inherently much more resistant to wet stacking.
So they handle low load better.
They handle it significantly better than older designs. Their combustion is just much more efficient across a wider range of operating conditions. This means that for some of these advanced generators, the traditional monthly loaded exercise might not be strictly necessary anymore.
Really? What's the alternative?
The thinking is shifting. It might be acceptable to do an unlighted exercise run monthly. Just starting it up to circulate fluids and check function, combined with a proper load bank test annually.
Annually instead of monthly.
Yeah.
That could be a big saving in fuel and time.
Huge savings, potentially less fuel consumption, less wear and tear from constant heavy testing, and some studies even suggest significantly lower overall emissions, maybe up to 70% less pollution compared to doing loaded tests every single month.
But you still need some form of regular testing.
Oh, absolutely. You still need to meet regulatory requirements like NFPA 110 in the US for emergency systems, which often mandates monthly exercise for 30 minutes, specifying either 30% of the rated load or running under conditions that achieve the manufacturer's minimum recommended exhaust gas temperature. So that annual load bank test becomes crucial for verifying capacity and cleaning things out.
Okay, so load banking, whether monthly or annually, depending on the tech, is key. How do facilities actually do this load banking?
There are a few ways. Some larger facilities have permanent automatic load banks installed as part of their system. Others might have manual connection points for facility staff to use, or very commonly, portable load banks are used. Your generator service provider will bring a portable unit out during routine maintenance visits and perform the test then.
Got it. So load banking is number one. What else is critical for prevention?
Well, going right back to one of the main causes, correct generator sizing. This is absolutely fundamental.
Don't buy bigger than you need.
Precisely. Avoid the temptation to oversize the generator just in case. You really need to match the generator set's capacity to the actual loads it will be powering. And an oversized generator is practically guaranteed to run at low load most of the time, setting you up for wet stacking.
Makes perfect sense. What about just using it regularly?
Yes. Consistent use at its proper load level is vital. Like we keep saying, diesel engines are designed to work. Regularly running the generator under a decent load, getting it up to optimal temperature, helps prevent the buildup of both unburned fuel and moisture. Don't let it just sit idle for months on end if you can avoid it.
And fuel quality, does that matter?
It definitely plays a role. Always try to use high-quality, clean diesel fuel from a reputable supplier. And if your generator sits for long periods between uses, especially in storage, consider using a good quality fuel stabilizer. Diesel fuel can degrade over time, and old or contaminated fuel won't burn as cleanly.
Okay, so good fuel, right size, run it properly. What about basic maintenance?
Regular maintenance is your ongoing defense. Simple visual inspections go a long way. Look for leaks, any loose connections, signs of corrosion. Check that cooling fins and exhaust outlets aren't blocked. Stick religiously to the manufacturer's schedule for oil changes. And crucially, use the correct type and grade of oil. Check the oil level frequently.
Battery checks too.
Yep. Battery maintenance is important for ensuring it starts reliably when needed. Keep terminals clean, connections tight, and maybe do periodic voltage tests. And of course, schedule professional servicing at the recommended intervals. Technicians can perform more thorough checks, diagnostics, and catch potential issues early.
One important note here, if you have those modern after-treatment systems we talked about, SCR, DPF.
Yes, absolutely. If you have those systems, it's even more critical to follow the manufacturer's specific maintenance recommendations. Don't just change the schedule without consulting your dealer, service provider, or the manufacturer directly. Their requirements might be different.
Okay, that's a solid set of preventative measures.
Yeah.
Now, the tough question. Let's say someone listening suspects they already have wet stacking happening. Can they fix it themselves?
It depends heavily on how far it's progressed. If you catch it in the early stages, maybe you're just starting to see that black ooze or the engine seems a little sluggish, then yes, there's a good chance you can address it yourself.
By running it hard.
Essentially, yes. The fix is often the same as the prevention. Load banking. Run the engine under a heavy load, ideally at or near its maximum rated capacity, or at least that 75% or higher mark we discussed, for a sustained period. Manufacturer guidelines might specify an hour or two. This high-load operation forces those internal temperatures and pressures up, which can help the piston rings scrape off light glazing and, more importantly, burn away the accumulated carbon and unburned fuel deposits.
Would you see anything during this process?
You might see a fair bit of black smoke coming out of the exhaust initially as all that accumulated gunk is burned off. That's actually a good sign. It should clear up as the engine cleans itself out.
Okay, so early stages, maybe DIY is possible with a good hard run.
Mm-hmm.
But what if it's more advanced, if it's been happening for a long time?
Well, if it's reached an advanced stage, then no, it's almost certainly not a DIY fix.
Why not?
Because the damage might be too significant or even permanent by that point. If the cylinder glazing is severe, if the honing marks are obliterated, if the piston rings are actually seized in their grooves from carbon buildup, or if there are just massive deposits everywhere, running it hard won't fix that. In those cases, you're likely looking at a major engine overhaul.
Overhaul. That sounds expensive.
It is. It can involve completely disassembling the engine, potentially needing to rebore the cylinders, machine new honing marks onto the cylinder walls, thoroughly clean the combustion chambers, injectors, valves, maybe replace pistons and rings. It's a complex and costly repair.
Definitely a job for the professionals then.
Without a doubt. That requires specialized tools, knowledge, and a proper workshop. Not something to tackle in the driveway.
Okay, that leads us to probably the most crucial question for many owners facing repairs.
Mm-hmm.
Warranty. If wet stacking causes damage, is it typically covered?
This is where the news is often not what people want to hear. Based on information from major engine manufacturers, damage specifically identified as being caused by wet stacking due to prolonged low-load or no-load operation is generally not covered by the standard engine warranty.
Not covered. Wow.
Yes. They essentially view it as damage resulting from improper operation or application, not a defect in materials or workmanship. Running the engine without a sufficient load, say for an hour or more repeatedly, is often explicitly mentioned as a condition that can void warranty coverage for related failures.
That is a massive piece of information. It really underscores why prevention is so incredibly important. The financial risk falls squarely on the owner if they let wet stacking happen.
It really does. It highlights that managing the load isn't just about performance or longevity. It's also about protecting your warranty coverage and avoiding potentially huge out-of-pocket repair costs.
So bringing this all together, it seems the core message about wet stacking is pretty clear, isn't it?
I think so. It really boils down to understanding that diesel generators are built to work, and working them correctly is the best way to keep them healthy.
Letting them idle or run under very light loads for long periods is just asking for trouble.
Exactly. Consistent load management, whether through actual use or proactive load banking, combined with sticking to the recommended maintenance schedule, using good fuel, and ensuring the generator was correctly sized in the first place, That's your best defense.
A well-maintained, properly loaded generator is a happy generator.
It truly is. It will perform better, last longer, be more reliable, and ultimately cost you less in the long run compared to one that's neglected or constantly underutilized. It avoids that slow, costly decline into wet stacking damage.
So the final thought for everyone listening is perhaps to take an honest look at how your generator is being operated.
Right. Ask yourself, is it really getting the workout it needs? Or is it potentially, silently, building up those damaging deposits? Because ensuring it works hard enough isn't just optional, it's fundamental to ensuring you have power when you need it.
Excellent point. Well, this has been incredibly informative. Hopefully, this gives all of you listening a much clearer picture of wet stacking and how to handle it. If you have more questions, or if you're looking for high-quality diesel generators designed with modern efficiency in mind, or need service solutions like load banking, be sure to visit us at auroragenerators.com.
So right, lots of resources there.
Once again, that's auroragenerators.com. Thanks for tuning in, and stay powered up.